Hello guys, welcome back to another week of school. This week we are starting with absolute value equations. This is section, not that it really matters to you, but 1.4. So last week we reviewed solving equations, throwback to Algebra 1. Now we're going to be solving absolute value equations. This may or may not be a throwback. It depends on, what school you're from and how, deep you went, things like that. So for an Algebra 2, you could consider it a review topic for some or new material for others, and it's totally okay. So basically we're doing equations with absolute value. So we need to talk about what is absolute value, and then how do you solve those equations. We're actually going to spend 2 days on this. So tomorrow's lesson will be an extension of this. Okay, the actual definition, the absolute value of a number is the distance between the number and 0, like if you were looking at a number line. So the absolute value of -5 right here is 5, because the distance from here to here, if you're going to count, is 1, 2, 3, 4, 5 spaces. So we count that way, it's 5. The absolute value of 3, the distance between 0 and 3, is 1, 2, 3. So what we have is these bars. By the way, I guess I should have mentioned that. These two parallel bars that surround a number are called the absolute value bars. That's the symbol that's used to represent absolute value. Basically, what you should have learned by now to already do is whatever number is inside the bars, make it positive. If it's negative, you make it positive. If it's positive, it stays positive. So absolute value is that thing that always turns stuff positive. But then we come to the question, what if you have an x in those bars? Because you don't know whether x is positive or negative. X is a variable. It's unknown. We don't know what it is. If x is a negative number, then you would have to, here, how am I going to do this? If x was a negative number, then you would have to make it negative, because two negatives make a positive. If x was already positive, you would leave it positive. So when you do the absolute value of a variable, there's two possible outcomes, and you have to represent both of them. So for example, if I say the absolute value of x is 5, what is x? You don't know whether x was originally a -5 or was x originally a +5. If it was negative, it got turned positive, just like you're supposed to do. And if it was positive, it stayed positive. So when you have a variable inside the absolute value bar, oh, here, let me go down here. Therefore, if you have absolute value bars on one side of the equal sign, you must split it into two equations and solve. Now here, there's no solving. You just split it into two equations and that's it. But you have to imagine that when you start doing algebra, there's going to be more work. So you're going to split it in two and then solve. 1 positive, 1 negative. So as I go through the examples, that's exactly what you're going to see me do. As normal, I'm going to do the evens as my examples, and I'm assigning the odd ones as your homework. Don't forget to grade your work and write a grade either up here or type your grade in the comments, please. Okay, the first 4 problems, again, I'm only doing 2 and 4, but the first 4 problems are very easy. Just almost nothing to it. But after that, they're going to get more complicated and they're going to involve more work. You can see it goes up to 20, which means you're going to have 10 homework problems. The first couple, super simple. So let me start with number 2. If absolute value of n equals 7, solve for n. So you need to split this, oops, let me get the pen, split this into two equations. One, n equals +7, the other one, n equals -7. And you're done. Those are the answers. Let me scroll down to number 2 so you can check it. And here they are. Now they wrote it, instead of n equals +7, n equals -7, they just combine them together in those little brackets, or they're called braces, to be honest. That's okay. That's just a detail. Okay, number 4. Absolute value of x equals 5. Solve for x. You split it into two separate equations. One, x equals +5, and the other, x equals -5. And then I'm doing air quotes, solve it. Well, there's nothing to solve. Those are the answers, 5 and -5. Scroll down and check number 4, 5 and negative 5. Okay, so those were ridiculously easy. Now they're actually going to start involving math work. So number 6, absolute value of 6p equals 24. Split it into two problems. 6p equals 24 and 6p equals negative 24. So one positive, one negative, and then solve it. So these we actually have to do algebra. I want to isolate p, so I need to divide both sides by 6. I get p equals 4. Over here, isolate p, divide both sides by 6. P equals negative 4. So my answers are 4 and negative 4. Let me check the work. 4 and negative 4. Now I'm seeing a pattern. 4, negative 4, 5, negative 5, 7, negative 7. Does that mean the answers are always going to be the same, just one positive, one negative? Now, be honest with yourself. Is it ever that easy? No. Let's look at number 8. N plus 5 equals 1. N plus 5 equals negative 1. Split it in two, one positive, one negative. If I solve the first one, I'm going to have to subtract 5 on both sides. 1 minus 5 is negative 4. For the other one, I have to subtract 5 on both sides. N equals, what's negative 1 minus 5? Negative 1 minus 5 is actually negative 6. So it's not the same number, one positive, one negative. I got negative 4 and negative 6. Let's scroll down and check number 8 to make sure I did it right. And there it is. By the way, if you're asking yourself, why does he keep checking every single problem even when they're easy? The answer is, you won't believe what I've messed up before. What should never have made a mistake, I can make a mistake. So trust me, it's in your benefit for me to always check my work all the time. All right, back to it. Number 10. Now, what I am about to do is wrong. So hear me out. I'm making a mistake on purpose to illustrate to you what not to do. I do this every so often, so please be aware. What I'm about to do, it's going to be wrong, then I'm going to erase it and then redo it correctly. So this would be your mistake. Absolute n minus 8 minus 10 equals 5. Absolute n minus 8 minus 10 equals negative 5. Split it in two, one positive, one negative. Well, that's totally consistent with every other problem I did. How could it be a mistake? Well, I could actually work them out. Oops, well, I guess the absolute goes away once you do this. I could work these out, get the answers, and then show you that they're wrong. But trust me, they are just wrong. It's not going to work here. The deal is, when you split it up, you're only allowed to split this into two when one side of the equal sign is just the absolute value. Just absolute value, just absolute value, just absolute value. You can have stuff inside the absolute value bars, like the plus 5, totally okay. But what you can't have is something outside the absolute value bars. That, if you split it up, wrecks everything and then ultimately gives you the wrong answer. So that's why that's wrong. Now I'm going to do it the correct way. So the first thing you need to do, eliminate numbers outside of the absolute value bars. You have to do that first no matter what. So I'm going to add 10 to both sides first. And I get absolute n minus 8 equals 15. Now I have just absolute value bars on one side. This is where you're allowed to split it in two. N minus 8 equals 15. And then n minus 8 equals negative 15. One positive, one negative. From here, solve it. So that means I'm going to need to isolate n by adding 8 to both sides. 15 plus 8 is 23. Same thing over here. Isolate n by adding 8 to both sides. That cancels out. Negative 15 plus 8 is negative 7. So positive 28 and negative 7 should be my answers for number 10. Where am I? 28. Ooh, 23. What? I made a mistake. Oh, duh. Stupid mistake. 15 plus 8 is not 28. That's just dumb. 15 plus 8. 5 plus 8 is 13. Carry the 1. 1 plus 1 is 2. It's 23. Sorry about that. See? Mistakes. This illustrates a good point, though. If you're doing your homework and you check it and you get a mistake, I'm asking you to fix your mistakes. That doesn't mean you have to go up here and, completely scribble out your work and redo it or erase it and redo it. You can just edit the work once you find your mistake and make it good, and that's fine. Totally okay. Okay, number 12, back on track. So again, you should not have any numbers outside of those absolute value bars. You cannot split until that is gone. So I need to eliminate this minus 5. How do I do that? I add 5 to both sides. Cancels out. Absolute p over 5 equals, what's negative 4 plus 5? 1. Now that the absolute value bars are the only thing on the left, I can split this in two equations. P over 5 equals 1. P over 5 equals negative 1. To solve this, to isolate p, well, we do opposite. What's the opposite of divide? Opposite of divide is times. Multiply both sides by 5. This cancels out. You get p equals 5. Over here, again, multiply both sides by 5. This cancels out. Negative 1 times 5 is negative 5. So 5 and negative 5 for number 12 should be my answers. Where are we? Number 12. 5 and negative 5 right there. Good to go. Number 14. Once again, a number outside of the bars, you have to eliminate that. It's positive 6, so I'm going to subtract 6. If I do that, they cancel out. I get absolute 2b minus 4. Okay, you can't make your absolute bit value bar look like a 1, so draw it bigger so it looks like the actual bar. 22 minus 6 is 16. Now I can split this into two separate equations. 2b minus 4 equals 16. And yes, I know that my b's look like 6's. It's been one of my flaws all throughout my career as a teacher, and I do not know how to make a b look less like a 6. Okay, so anyway, on one side you set it equal to 16, the other side negative 16, and then you have to solve both of these. Now this is going to be a little more work. So add 4, 2b equals 20, then divide by 2, b equals 10. Over here, add 4, 2b equals negative 12, divide by 2, negative 12 divided by 2 is negative 6. So the two answers should be 10 and negative 6. Let me check number 14. 10 and negative 6 right there. All right, if you think you've got it at this point, I would not feel bad if you stop and then go ahead and start working on your homework. Remember the odds, grade it, write the grade on your paper or write the grade in the comments. Make sure you always do that. If you don't quite get the hang of it yet, just hang with me and I'm going to keep doing more examples. You can see at the end they get fairly complicated. Okay, number 16. Once again, any number that's not in the absolute value bars, you have to cancel that out or eliminate it. So minus 2 minus 2. I get absolute 4n minus 3 equals 42. Now that the absolute value bars are all that's left on one side, you can split it into your two separate problems. 4n minus 3 equals 42. And 4n minus 3 equals negative 42. One positive, one negative. Solve each one by doing normal algebra steps. So I get 4n equals 45 plus 3 plus 3. 4n equals, what is that, negative 39. Now I need to divide both sides by 4. That equal sign look better. 45 divided by 4. 4 doesn't go into 45. I'm going to hold off on that for just a minute and see if the answers are fractions or decimals or what. Same thing here. Negative 39 divided by 4. Well, yeah, I'll just scroll down to 16 and check it. Ooh, that's not even close. What did I do wrong? I made a mistake. Rats, rats, rats. Where am I? Okay. I gotta double check. Oh, stupid. Oh my gosh. Of all the stupid things. What's 45 minus 2? It ain't 42. It's 43. Good grief, you're a genius. Okay. So this was supposed to be a 43. And that means that this was supposed to be a 43. 43 plus 3 right here, that's 46. That's 46. And you can reduce this, since they're both even numbers, to 23 over 2. And then this other one, negative 43 plus 3, that's negative 40. Negative 40 divided by 4 is negative 10. So these should be the answers. Let me check now, number 16. And there it is. Okay. Good. So, wow, 2 mistakes in 1 lesson. And I still have 2 problems to go. Lucky you guys, getting quality education here. Okay, but yeah, seriously, let's learn from Haskell's mistakes if you can. See how I correct my mistakes so you know how to correct yours. I don't expect you to scrap everything and start over. Just find your mistake, go back and fix it. Okay, number 18. Do you see this right here? Here is a mistake. Some people do negative 9 plus 7, negative 2. 9n minus 10 equals 110. This is wrong. This is wrong, wrong, wrong. Here's the deal. If you had a problem that said negative 9 plus 7x equals 110, could you add the negative 9 plus 7? You should be saying no, because the 7 has an x to it, the 9 doesn't, so these aren't like terms, therefore you cannot combine them. This 7 is basically attached to all of this, which does have a variable in it. Therefore, these are not like terms, the negative 9 and the 7, and you cannot combine them. So, the right way to work out number 18 is like this. Add 9 to both sides. You get 7 absolute 9n minus 10 equals 119. Make that look more like a 9. Since this is times, I'm going to divide both sides by 7. And I get absolute 9n minus 10 equals, what's 119 divided by 7? 7 goes into 11 once, with 4 left over. 49 divided by 7 is 17. So 119 divided by 7 is 17. Use a calculator if you need to do that on a calculator, no big deal. Now the absolute value bars are by themselves on one side of the equal sign. This means it's okay to split into 2 problems. 9n minus 10 equals 17, and 9n minus 10 equals negative 17. So I had 2 numbers not in the absolute value bars. I eliminated them both by using basic algebra steps. Then I split the inequality into, the absolute value into 2 equations. Now I can solve them both. Add 10 to both sides. 9n equals 27. Divide by 9. n equals 3. Add 10 to both sides. My dogs are about to go nuts. Just if you hear them howling in the background, it's because the noon siren is going off. Negative 17 plus 10 is negative 7. Divide by 9. Negative 7 ninths is a weird fraction. It does not divide out. Let me go check the answer key and see if that is okay. Yeah, and there it is. 3 and negative 7 ninths. Yep. Can you hear my dog howling in the background? Yep. You heard the fire whistle. They test it every Wednesday at noon, and now he's going nuts. Okay, I'm going to go ahead and try and finish Number 20, even with the commotion in the background. If my microphone's not picking up, hey, great. Okay, so I need to eliminate the 6 and the negative 4 from outside of those absolute value bars. Oops, let me get back to pen. Minus 6. Negative 4, absolute, negative 9n minus 9 equals negative 72. Divide both sides by negative 4 because this is times, right? When a number sits next to something, it means times. So do the opposite, it's divide. I get absolute negative 9n minus 9 equals negative 72 divided by 4 is positive 18, I believe. Yeah, use a calculator if you need to. Check on that. Now I have the absolute value bars alone on one side. I can split this into two equations. One positive, negative 9n minus 9 equals positive 18. And the other negative, negative 9n minus 9 equals negative 18. Notice, by the way, I didn't change these signs. You don't change those. You change the 18, well, leave it positive and then change it to negative. Okay, let's finish this off. Add 9 to both sides here. Negative 9n equals 27. Divide by negative 9. 27 divided by negative 9 is negative 3. Here, add 9 to both sides. Negative 9n equals, okay, what's negative 18 plus 9? That's negative 9. Divide by negative 9. Negative divide by negative is positive. Positive 1. So the last problem should be negative 3 and positive 1. And there it is. Okay, so they start off kind of easy, where you basically, where am I? Right here. Basically do no work at all. Just split it in two. Then split it in two and do a couple of steps. Then you have to do, eliminate a number outside of the absolute value bars, then split it in two and solve it. And then it just gets a little more complicated as you go till you get to the very last one that's got a whole lot of steps. Work yourself up to it, check your work, fix your mistakes. I've obviously demonstrated what it looks like to make mistakes. Check yourself, give yourself a grade, tell me the grade. So again, either write the grade on the paper when you submit it or type the grade in the comments. If you do have questions, email me or use the comments to ask me a question, and I will talk to you real